Okay, let's get going. Welcome everybody. Good morning and thanks for taking about half hour out of your busy schedule. My name is Marcus. I work as a technical manager for SOLIDWORKS based out of Stockholm. And I think we are going to start with one of the most important things, which is a small poll. I need to know whether or not you can hear me or not. And I should also mention that this webinar is being recorded, so if you have technical issues you will be sent a link, and for those of you that think it's really interesting you can watch it over and over and over if you want. Alright, most people can hear me, which is a good thing, so let's get started. So today we're going to be speaking about SOLIDWORKS CAM. It's CAM programming inside of SOLIDWORKS. It is not something we invented ourselves, but we have partnered with CAMWorks to make sure that we get the best possible solution for our SOLIDWORKS users. The product itself will cover part and assembly machining. We are focusing this time on 2.5 axis machining, but we include 4 and 5 axis positioning, and this has shown to make up for about 85% of all the machining done in the world today is covered by 2.5 axis plus the positioning. On top of this, we are also including 2 axis turning in the package as well. It also comes with a toolpath simulation package, so anything you do, you program, you will be able to simulate to make sure that you get the material removal you're interested in, and also that you avoid collisions with your fixture components. We also have a library of post-processors with the program, and it also comes with a development tool for those of you inclined to make your own post-processors. So today we're going to go through the process of programming a part in 4 steps. We're going to begin with creating the setup and fixture documentations. We're then going to move on to programming the part itself. We're going to look at high-speed machining, which is part of SOLIDWORKS CAM as well. And finally, we will be looking at design changes and, of course, outputting the code and post-processing it. But let's start from the beginning. Let's start with how to make a fixture setup. So of course we're using SOLIDWORKS with this, and we're going to look at how to use template to make sure that we always have the same setup and we can keep the same documentation. We're going to see how SOLIDWORKS actually automates the stock sizing for us, and also how we can use SOLIDWORKS drawings to have associative documentation around all of this. So by using SOLIDWORKS to create and reuse templates for fixtures is a great way to reduce time spent for just setting up our shop floor documentation. So for us to use this to program this part, I've had this stock template set up, and it also comes with a fixture sheet using SOLIDWORKS drawing, so that's already predefined. And the next thing we need to do is find the component we are going to program. So just like with any SOLIDWORKS assembly, we can quickly and easily drag this into the assembly and position it very, very quickly and efficiently. But since we're using templates, we can also use predefined geometry. In this case, we have a plane that's always sitting 1.5 millimeters away from the vice jaws. That means that we know that this part will always have enough stock to actually hold it in the vice itself. Next, we can simply realign this if we need to, and select whatever is the most efficient way to hold this. And with SOLIDWORKS, it's basically a button press away for the SOLIDWORKS automation part to just adjust the stock for us and also adjust the fixture for us. Now, this might not be the most efficient way to do this, so let me just rotate that back for you and quickly mate this into position with standard SOLIDWORKS mates that you all know and love. And we're quickly and easily set up, and we'll have the stock again repositioned and recalculated for us. We're here using a bit of standard predefined views as well within our template to make sure that we always have the good clean view of what we're programming. Some final adjustments to make sure that we're within the stock boundaries that we want to use. And we're almost ready to go. If we look at this, we see that this part is bigger than the jaws, so we could quickly and easily just use SOLIDWORKS configurations to select a bigger jaw for our vise to make sure that it actually sits a bit more tight in position. It's just a button press away. And next we might also need a few more clamps to hold this. And like any SOLIDWORKS assembly, it's a matter of holding Control key down and dragging and dropping these clamps to make sure that we actually have more of them. So setting up your fixtures in SOLIDWORKS CAM is super quick and super easy, just using techniques that you already know. We might want to switch back to the drawing at one point to make sure that everything is updated, that we actually have our part in there and all our new clamps and fixtures. We want to fill out this sheet, and we can do that in either way, just typing the interesting information in that we need, or having predefined drop-down boxes. Whatever suits your manufacturing process, we can make that happen within our template setups. This really cuts down the time it takes to do the initial setup before we can start programming our part. We can also have these placeholder balloons that will exist within the drawing, within the setup, but as we start populating our model with components, they will actually change and update and make sure that we actually have everything that we need. So we've seen by using SOLIDWORKS, the assembly that we need to set up for our fixturing is done super quick, super easy, and it's also very repeatable since we're using a template setup. The stock sizing is automated. SOLIDWORKS CAM will automatically pick a stock size for us that is closest to whatever we can purchase maybe. And also SOLIDWORKS drawings is used to make sure that all the documentation that we create is fully associative to whatever we're doing. Next, we're going to move into part programming. See how to program this part using SOLIDWORKS CAM. SOLIDWORKS CAM is super quick and intuitive to use. It uses automatic feature recognition. This is really good because it allows us to set up a library with features that we often machine and have the software automatically select whatever is in the database that we have done before and we know and trust. This also means that it doesn't matter where the part comes from. It might be a SOLIDWORKS part, it might be an imported part from a different CAD system. We will still use the same feature recognition to be able to automatically put strategies on these parts as well. For those of you that use SOLIDWORKS MBD, that means that you put PMI, 3D dimensions and tolerances on the model itself. This can also be used as a base of selecting the applicable strategies. And at the same time, at the end of the program or the end of the demo, we will see how we can update the geometry and have everything update with the ANSI program. And that is also true for changing a tolerance within the MDB scope. That new tolerance might need a new machining feature or a machining strategy, and that's what's going to happen. So we're done the part setup already, and if we look on the left side, we have the machining tree where we have the machine itself. For example, we can select any type of machine in our library. In this case, we'll do the Haas VF3 machine. This also comes with its own tool crib, for example. So we have a pre-set up post-processor, and we also have a pre-set up selection of tools that always comes with this machine. So having done that, the next thing we need to do is tell SOLIDWORKS CAM of all these parts in this assembly, what are we going to machine? It might be one part, it might be a set of parts that we're machining in one setup. We just need to let SOLIDWORKS CAM know what part to actually program. So the workpiece can be set up in any type of way. We can have automatic workpieces, we can have a SOLIDWORKS part, we can import an STL file, maybe an in-process file. In this case, we have a stock from the template that we're using. So we're going to pick in that sketch, and that basically gives us the stock that we want to use for this program. We also see in the bottom that we actually have those 1.5 mm to make sure that the clamps always grips the part whenever we are programming it. Next, we actually have SOLIDWORKS CAM automatically recognize all the features that are machinable in this part. And it takes a few seconds, and we'll get a complete list of things that we can actually machine in this part. We can step through these to make sure that these are exactly what we were expecting to see. And if there's anything in here that we don't want, we can just quickly remove a couple of these features that are not usable or not interesting for the moment. But we can also have a look here. Since this is automatic, we can still change some parameters. For example, I do not want this to machine all the way through the stock. I just want it to go to the bottom of the part. Some of these features come with built-in intelligence. These holes was created with the SOLIDWORKS Hole Manager, and they're defined as a threaded hole. And SOLIDWORKS CAM will automatically recognize that as a threaded hole as well. And we'll see what happens when we generate the program for it. So generating the operation plan basically goes and gets all the machine strategies that we have predefined and puts them on these features automatically. And this is how quickly and easily we have actually programmed the part. Now, this might not be the exact way we want to do it, but it's actually already done. So generating the toolpath, we'll see that it's already done. So this is a very, very quick and easy way, and we see that we also have the thread mills and the taps that we were expecting because of these threaded holes. We might want to go in and work a little bit more with this. For example, we have these fixture components, so we're adding those into the assembly quickly and easily to make sure that SOLIDWORKS CAM knows what not to run the tool through. This is a huge advantage of working with the entire assembly. And like I mentioned before, we have a complete simulation setup as well, so we can always look at the material removal as we go. Now we see in the blue here on the top of the part, we actually have material that wasn't recognized by the feature recognition, so we need to be able to take that material away. So if there's anything that isn't automatically recognized by SOLIDWORKS CAM, we have the possibility to very quickly manually do that. So in this case, we're going to say that we want to have an open pocket, and we'll pick the geometry that we want to machine. And we also want a rough and a finish, and we'll see whatever comes out of my technology database. And we also machine that up to stock. So that takes about less than half a minute to set up. We also have some other things. We might not want to crash into these little islands that's in the part, and SOLIDWORKS CAM automatically recognizes what those are to make sure that we don't run into them with the tool. Then we'll generate the operation for that as well, and we'll see what we get. That's probably what we expected. However, these parts we want to do early in the program, so we can just drag and drop them anywhere in the operation tree to have the easy way that we want to machine this. This is not the only way to sort operations. You can basically just say that, you know, we want to run them by operation type, so all the roughing first and then the contouring, or by tool, depends on how we want to do it. and we'll get all that done by SOLIDWORKS CAM. If we have several machining strategies that are basically the same with the same tool, we can easily just combine them into one program, so we get less tool changes and we get a much neater and nicer program to run. And let's have a look at what we're actually getting now. That looks a whole lot better than our first, and we see here that we have saved those 1.5 millimeters of stock, so we're actually clamping down the part really good at this point. So in just a few minutes we've seen how we can use SOLIDWORKS CAM with automatic feature recognition, immediately find everything that's machinable within our part, even if it's native or if it's imported. This also means that the manufacturing that we're actually generating, or the strategies, if we use a strategy and we find that it's not good enough and we change it, adjust it, it's saved back into the technology database. So next time we are machining the same thing, it will actually use the updated one. So your technology database will be refined to perfection after a few months of use. And like you've seen, it's very, very easy to learn, and it's very, very intuitive. So the next step is looking at how can we refine whatever we have done with high-speed machining. So high-speed machining is part of SOLIDWORKS CAM. It allows us to reduce programming time as well as machining time. It allows us to have a better, more even, and much less wear of the tool, and also our machine itself, since it has less load on the spindle and the entire structure of it. So we'll start at looking at the part that we just programmed. And the first thing we want to do is look, how long does this take to run? This entire program will run for about 42 minutes programming this part. That's a long time for this part to run. And also, if we look at the roughing operations of this part, we'll see that the roughing operations actually take the longest part of this. So this first roughing operation is almost 14 minutes out of those 42. There's a significant part that's spent just roughing this part. So quickly and easily we can just select a different strategy, which is the high speed one. High speed in this case means that we are allowing the machine, or we're allowing SOLIDWORKS CAM to vary spindle speed and vary feed rates to automatically get the result that we want. We can also tune a little bit on how deep are we starting, is this aggressive, is this a conservative programming method, and a few seconds after we have generated a new high-speed program for this. And if you can see here, you see that it looks significantly different. It's got smooth tool movements all around. It's no jerking. It's no quick entry into the part. And we went from almost 14 minutes to 1 minute. That's over 90% saved time in just one roughing operation. So if we do this without explaining so much, we'll just take the next roughing part and just change those parameters, see what we can get from these 14 minutes. Move into high speed, set the parameters we need for this specific operation. We'll do it halfway between conservative and aggressive. Let it calculate, and we'll see what we're getting time-wise. We're getting 2 minutes instead of 13, so that's a huge saving in time for programming or running this part. If we're looking at the tool path, we'll see again how the feed rate is constantly changing to make sure that the tool has the best possible working environment. And this entire program went from 42 minutes to 17.5. That's a huge saving. Imagine you're doing 10, 15, 20 of these parts. That's hours and hours of machining time we just saved by applying high-speed technology to this part. And again, let's simulate this so we see that the result we get is what we're expecting. And that's as quick and easy as that is done. So with high-speed machining, we've gone from 42 minutes to 17.5 by just adjusting a few of these settings within SOLIDWORKS CAM. It's a massive time saver. Almost 60% in this part itself. I am going to run another poll here. We're not really done with the presentation. We have one more step. But I'd like to know what you're working with today in your CAM environment. I'm just going to let this run for about a minute, maybe. That's great. Thank you so much for that. And also, before we run the last segment, I would like to know if you find this interesting and want to have more information. I'm going to let this run for another 15 seconds maybe. Perfect. Thank you so much. And one final question before we do the last segment. Do you like our webinars? Do you think they're worthwhile? Do you want to have more information about them? Perfect. Thank you all so much for your responses. Let's move on. Right, so we've seen how we've gone all the way from setting the scene, so to speak, the information that we need to produce the part, to programming it, to finalizing it with high speed. Now we want to know what happens if we change this part. So this is one of the key points of using SOLIDWORKS CAM. It's always associative to the model. Any changes we do on the geometry, they will be immediately applied to the machining options that we have and the toolpaths. And we're also going to post-process this. Remember, we chose the Haas machine in the beginning, and that has a post-processor tied to it. And we also have an NC editor that allows us to edit, view, or even send it like a DNC system to our machine. So since we're working fully integrated within SOLIDWORKS with SOLIDWORKS CAM, it's really easy to just grab the part, open it up in its own window, find whatever it is that we need to change. In this case, we'll change the wall thickness of this little pocket here. And we'll see that the SOLIDWORKS model, of course, immediately updates. And when we switch back to SOLIDWORKS CAM will just tell us immediately that, guys, this part has changed. We need to update 15 features. And we'll just allow it to do that. And it calculates for a few seconds, but it also calculates all the toolpaths for us. So changing the part is as quick as that, and there's no redoing of programming. It all updates automatically. So let's run this program and post-process it. We save it to a text file, and we have the post-process already selected. We could, of course, select another one if we absolutely need to. We can either step through the program or just post-process everything at once. Now, this is not the best way to look at it, but we can just easily open it in the NC editor instead. And the NC editor will bring it up. We can look through it and make sure that this is what we are expecting to see. If we need to edit it, we can do here. Otherwise, we'll just send that to the machine and we are ready to go. And while this has been working, in the background, of course, all the documentation that we've done. So if we look at the fixture sheet, we'll see that the part has been updated even here. So anything we've done completely flows downstream with the model as the base. And this is the power of SOLIDWORKS CAM, SOLIDWORKS being an integrated solution. So as we've finally seen, we have seen how everything is associated to the model. Every design change will be automatically handled by SOLIDWORKS CAM. There is post-processors available, and our partners will also make them, but we also allow you to make your own with the tool if you are so inclined. And we've also seen how the NC editor can be used to look through the program, do some edits if we need to, and even work as a DNC system to push it away to the machine. SOLIDWORKS CAM allows you to program smarter and machine faster and have everything in one solution from one vendor. And that, my friends, is the full half hour gone. I thank you so much for taking your time out of this morning. Like I said earlier, the webinar will be or have been recorded and will be sent out to you so you can spread it to your colleagues that couldn't attend. And if there's any questions, this is my email. Don't be shy, drop me a line, and we'll see if we can help you. Thank you very much. Goodbye.